In the last video, we saw how to draw dot structures for molecules with single covalent bonds. In this video, we'll talk about multiple covalent bonds. And so we start the same way we did in the last video. If I wanted to draw the dot structure for C2H4, I would find carbon over here, and once again, carbon is in group 4, so it has 4 valence electrons. So I'm going to go ahead and put in one carbon with 4 valence electrons. And I know I have another carbon in my dot structure. It also has 4 valence electrons, like that. And so immediately I can see there's going to be a single covalent bond between my two carbons, like that. 4 hydrogens, and I know that since hydrogen is in group 1 on our periodic table, hydrogen has 1 valence electron. Now it makes sense to go ahead and put 2 hydrogens on each carbon. So if I put 1 hydrogen over here and then another hydrogen on this carbon, I have 2 more hydrogens, and so I can go ahead and put in those 2 hydrogens in the carbon on the right. When I connect my dots, I can see that I have a bond between carbon and hydrogen here. And this is not the correct dot structure, because if you count up the number of electrons around carbon, so let's go ahead and do it. Let's do the carbon on the left. I'm going to get 2, 4, 6, and then 7 electrons. So with only 7 electrons around each carbon, carbon does not satisfy the octet rule. So the only way for carbon to get an octet of electrons around it would be if this magenta electron moved in here and this electron moves in here to form a double covalent bond between those two carbons. And so now, instead of only having 1 bond between those carbons, now there are going to be 2 bonds around it, like that. So I can go ahead and put in my hydrogens, so 2 on each carbon, and that is the correct dot structure for ethene or ethylene. We can double check by checking the octet rule here. So if I look at each carbon, there'd be 2 electrons, 4, 6, and then 8. So each carbon is following the octet rule for my dot structure. Let's do one for CH2O. So if I want to draw the dot structure for the molecular formula CH2O, once again I start with carbon in the center, so 4 valence electrons, like that. And 2 hydrogens, so I'll just put 1 hydrogen over here on the left and another hydrogen over here on the right. Oxygen, let's go back to our organic periodic table to refresh our memory about how many valence electrons oxygen will have. And we can see it's in group 6 over here, so 6 valence electrons. So I can go ahead and put in my 6 valence electrons for oxygen. And so we'll go 1, and then 2, and then 3, and then 4, and then 5, and then 6, like that. And when I start connecting my bonds here, I know there's a bond between carbon and hydrogen on the left. I know there's a bond between carbon and hydrogen on the right. I know there's a bond between this carbon and oxygen. And unfortunately, I still don't have an octet of electrons around my carbon or around my oxygen. Right? So if I go ahead and highlight the electrons around carbon, once again, I have 2, 4, 6, and then 7. So I still don't have an octet of electrons around carbon. And so I need to share an electron with oxygen here. So carbon is going to contribute an electron, and oxygen is going to contribute an electron, like that. And so instead of a single bond between carbon and oxygen, there's actually going to be a double bond, like that. There's still 2 lone pairs of electrons around that oxygen, and then I have my 2 hydrogens coming off of my carbon, like that. So that is the correct dot structure for formaldehyde. We can go ahead and double check an octet, right? So if I look at this carbon here, this would be 2, 4, 6, and 8, and obviously there's also an octet around that oxygen as well. So this is the dot structure for formaldehyde. Let's do one more example of a molecule with a multiple covalent bond. So C2H2. So once again, carbon with 4 valence electrons, and I have 2 carbons this time, so I go ahead and put in my second carbon with 4 valence electrons, like that. I can see immediately a single covalent bond between my 2 carbons. Now I have 2 hydrogens, so once again I'm going to put 1 hydrogen on the carbon on the left and connect that for a single covalent bond, and it would make sense to put the other hydrogen over here on the right and connect that for another bond. Now, once again, if I look at the valence electrons for carbon, I have a total of 2, 4, 5, and 6. And carbon wants to get to 8. It wants an octet. So it needs to share 2 more electrons. So each carbon needs to share 2 more electrons so each carbon can get to an octet. So we're going to go ahead and move this electron in here and this electron in here. And then we'd also have to move these electrons in here as well. So we're going to end up with a triple bond between my 2 carbon atoms there. So if I go ahead and show now 3 bonds between my 2 carbons and then a hydrogen on either side, we can double check the octet on the carbon here. So I'll get out the magenta again. So 2, 4, 6, and 8. So there is now an octet. And so this is the correct dot structure for ethyne or acetylene. And so we've seen how to draw molecules with single and multiple covalent bonds. And next we're going to talk about the hybridization states of different molecules that contain carbon.